Hello all, we are here for the lesson number 46 of this VariCAD training course, and this lesson is called Surface Development. In this lesson we are going to see about the unbending of sheet metal solids, or as I like to call, planification of sheet metal solids. I will start to show you the concept of this unbending by creating a very simple solid, just a box. So box created. Now it is a full solid. I will create a thin thickness solid. We've seen already how to do this. In this case it can be 1 mil, no problem. And okay, we have this thin thickness solid. So this unbending, it's obtained here in this objects menu, and then this function surface development. Inside VariCAD, this is a very simple solution. It's not really a full sheet metal package, so basically it does the unbending or the flattening, as you want to call it. But it is very accurate, and it is very interesting for a basic work of sheet metal work. Okay, so it's quite nice to work with this function. So let us see what we can obtain here. So surface development, and this dialog box is the basis of the functions we can have with this command. So to show you the concept, I will choose this create leader at each unbend point. We have some definition of the style, we have some flags and circles or whatever it is, and line types, colors. I will leave this, it's not very important for the concept. I will create the axis and will not write down the coordinates, we will see a little later. And we have this function here that is called unbend points distance for nonlinear curves. In this particular case, this is a flat solid, so this function will not be used, but let us see what we can do. Besides, we will not see it now, but or we will not use it now, but we can see what it is. This unbending have some mathematical definition behind, okay, regarding the coefficients and the sheet thickness of the metal. So we have a table here, and we can use these values. I suggest you to look a little on the internet about how this ratio and this bending coefficient works. Okay, I will not explain you this inside VariCAD. It's not the purpose of the software. You just need to understand how these work and use the proper coefficient. Okay, I will leave the default option and show you later what kind of result you get. For now, just do the OK, and we'll choose which are the surfaces to unbend. Okay, I will use this option, entire solid, click one of the outer surfaces. Okay, everything it is chosen in the outer surface of the solid, just do the OK. And I got a question that it is sheet thickness is significant. If so, just confirm the thickness. Now I will leave it hidden. Okay, just do the OK. And I got transport for the 2D side, where I can drag and drop the full solid open. So I will drop it here. And now I'm being asked about the origin of the coordinates. So I can say, for example, this point, okay, x and y origin. And for one of the functions that was on that dialog box, now I'm being asked about the points which are relevant to make a proper marking on a sheet metal or paper or whatever use I will make out of this. So all these points, they are marked. Okay, these are lines, so I just need to have the start and the end point. Okay, 12 points, that's it. Okay, very easy, very I think very straightforward, no confusion to use this. So I will clean this now. I will show you a couple more options you have on that dialog box. Again, to the 3D side, objects, surface development. You see, create leader at each unbent point. It was that 1 to 12 in this case. Create axis. It was the question that the system has made to position the coordinate origin. And besides, we can have this option chosen, which is for those points we can write the coordinates regarding the origin that we give on one text file. So choose this, give the file name, I will put it on the work environment, and just say coordinates. It's a txt file. Just save, and now do the OK. Choose again the same thing. OK, again not significant for now. Do the OK, position, give the origin, and put the points. Okay, so 1 to 12, and that's it. Now I can come to the work environment, and you can see 1 to 12 regarding x and y. These are the coordinates. Very useful, and you can use this format, for example, for a laser machine or some kind of CNC machine that deals with coordinates. So this is one possibility, but we can do other things, like, for example, a round thing. Okay, let us try to, I will delete this solid. I will make something round, for example, a little bigger. I can leave this 30. Okay, one cylinder. Let us make a smaller one, for example, like this. Let us position it. A little inside the solid. Okay, position it. I will make this base one a little bigger, because in the end it was not so as big as needed, so 50 it is good. Okay, very good. So now I will use a Boolean operation, you know it already, okay, and make one solid. So now I want to make the unbending of this round surface. Again, objects, surface development. I have all these options: create leader, create axis, write the coordinates. I will take this out, no need. And unbend point. I will give this a bigger value, for example 15, because in what it does, it is, as we will see, choose this, okay, not significant yet, and do the okay. So this is the solid. I can put the origin, for example, outside, and now, okay, That's what I want to show you. Now it's too big, but the idea is to show you the concept. So every 15 millimeters, that was what I choose, it will make an approximation of a segment between the 2 points. Okay, for sure 15 in this case it was excessive. You probably, to have something accurate, you should choose 1 millimeter or other things similar. But the idea I want to show it is that the software will make a split of the non-linear curve, in this case this round thing here, for the measurement I give on the dialog box. Okay, I could have these coordinates also written on the text file. I did not do it because it will have a similar result like the one you've seen previously. So just want to show you this possibility here of these points on this type of curve that it was not shown yet for you. Another case I want to talk to you about, it is to show you an example of a bigger thing. So we have, let me close all the files. Okay, couple of examples. Okay, we have inside VariCAD on the sample installation, we have one example for one sheet metal part. So let us try to do the unbend of this part. I will take this out, no need now, just unbend, do the OK, and I will choose this side. Okay, see, everything is chosen. I'm choosing everything, but I could choose just one part. Do the OK, take out the thickness, and it is here. Okay, if I don't like these lines that basically correspond to the fillets or the radius or whatever it is, I can go and take these out. They are entities, just clean them. Okay, very easy, because if you will cut this shape on a laser machine, you don't need these entities inside. Okay, this was another example for one of the sample files. Now what I would like to show you is about this function that I've been not choosing, which is regarding the thickness. And for that I will make a very simple solid. Let me try to make something quickly. Very easy shape. So -40, -40, 0, back to cursor, close it, and that's it. So I just want to make an extrude out. It can be 50, no problem. I just want to make an extrude out of this. Okay, and now I want to make a fillet on these two corners. Okay, so inside 10 mil radius, and outside, to maintain a constant thickness, 20 mil radius. So you see, this is a very basic solid, but it will allow us to see how to work with the thickness. So now I will unbend this shape. Okay, I don't care about all these things here. Just do the OK, choose the outer layer of the surface and do the OK. And now I will say the thickness is not significant first, so it will do the unbend, it is here. I will clean this shape here, and the unbend is done. Okay, I will make a dimension here to show how much we have. Okay, 91.42. If I go there again, and now I say surface development and do the exact same function outside again, okay, but now significant, and now it's getting 10 because you have 10 on the solid, but I will make 1, okay, I will put it on the side. Probably you see no big difference, but if you put the dimension, you see you have a difference, because and if you have 10 we can try, because this unbent of round areas, it has some math behind, so it is important to get the right thickness on the sheet metal that is going to be used. So let's try the 10 mil, just okay, 10, very good, and you see it's quite short now, and if you put the dimension also, you see very different. VariCAD in fact is very accurate in these calculations, so again it is important to have the right thickness if you think it is important to have an accurate part after being worked on the tool shop. Okay, so basically we are done with this lesson 46. It was the last lesson for this big chapter that we dedicated to the 3D side of the program. We have still 3 lessons to finish the training course, and these lessons will be about a complete new chapter that will take us to solid attributes, bill of materials, and this kind of topics. And I truly hope that all these previous lessons about the 3D side are clear, and I hope to see you in our next lesson.